Hello learners, I'm Teacher Sharon and I'm taking you through Form 4 Mathematics, and in this session we'll be looking at matrices and transformations. For this lesson we'll be describing a transformation, specifically rotation, using a matrix of transformation. By the end of this lesson you should be able to describe a given rotation using the matrix of transformation. The table below shows types of rotation with their respective matrices of transformation. And in this lesson, we will confirm the information which is given in the table. 1. Using the formula matrix multiplied by object should give you image. And Roman 2, using a trick which I will give at the end of the topic. Let us start with using the formula m multiplied by o is equals to I, and we'll start with the rotation through 90 degrees clockwise, that is a negative quarter turn about the origin. From the table we are told that the matrix of transformation to represent that should be 0, 1, negative 1, 0. So we'll prove this using matrix times object to give us image. The grid which is given below will be used for the clockwise direction, 90 degrees rotation. So we have, if we are rotating these coordinates which we have A, B, C, D, then A is in coordinate 0, 1, B in position 1, 0, and C position 0, negative 1, then negative 1, 0 for D. If we want to rotate in clockwise direction 90 degrees, then it means that A will be mapped onto B and D will be mapped onto A. So this means that if we take a matrix of transformation A, B, C, D, we multiply by the object, that is A, which is 0, 1, and the object D, which is negative 1, 0. Then this should give us the image coordinates, that is 1, 0, and 0, 1. Let's form simultaneous equations and solve them to get the value of A, B, C, and D. So the first row multiplied by the first column should give us this term, that is 0 multiplied by A will give us 0, plus B multiplied by 1, that is B, should be equal to 1. So the value of B is 1. First row multiplied by the second column should give us the second term, which is 0. So this is negative A plus 0 multiplied by B, which is 0, is equal to 0. So if negative A is equals to 0, then it means that A is equal to 0. Then we go to the second row multiplied by the first column, which will give us the first y coordinate, that is C multiplied by 0 to give us 0, plus D multiplied by 1 to give us D, is equal to 0. This means that D is equal to 0. Second row multiplied by the second column should give us the second y coordinate. So we have negative C, that is negative 1 multiplied by C will give us negative C, plus D multiplied by 0, which is 0, and this will be equal to 1. So if negative C is equals to 1, then it means that C is negative 1. So the matrix of transformation here, which is A, B, C, D, will be given as 0 for A, B is 1, C is -1, and D is 0. So we can confirm this from the given table, and that is true. So we go to rotation through 90 degrees and clockwise. That is a positive quarter turn about the origin, where we are told that the matrix of transformation should be 0, -1, 1, 0. So for this one, we are doing 90 degrees and clockwise. Again, we have the points A. The coordinates are 0, 1. B, coordinates 1, 0. C, we have 0, -1, and D, which is -1, 0. So if we do a rotation of 90 degrees in anti-clockwise direction, it means that A will be mapped onto D, and D will be mapped onto C. So we have a matrix of transformation which is A, B, C, D, multiplied by the object coordinates. So the object coordinate is the coordinate of A, which is 0, 1, and the coordinates of D, which is -1, 0, should give us the image coordinates, which are the coordinates of D, -1, 0, and the coordinates of C, which is 0, -1. This means that the first row and the first column should give us the first term. So A multiplied by 0 is a 0, plus 1 multiplied by B, which is a B, is equal to -1. This means B is -1. First row multiplied by the second column should give us the second x coordinate, which is 0. So we have -A plus 0 multiplied by B, that is 0, is equals to 0. So if -A is equals to 0, then A is equals to 0. Now we go to the second row. So the second row multiplied by the first column will give us the first y coordinate, which is 0. So we have 0 multiplied by C, 0, plus 1 multiplied by D, which is D, is equal to 0. And this means that D is equals to 0. Then we have the second row multiplied by the second column to give us the second y coordinate. So we have -1 multiplied by C, which is -C, plus D multiplied by 0, which is 0. That one will give us -1. And if -C is equals to -1, then C is equals to 1. Now, when we are writing this matrix of transformation, we'll have the value of A as 0, value of B -1, the value of C 1, the value of D 0. We can confirm from the table given, and yes, the matrix of transformation is 0, -1, 1, 0. Lastly, we have rotation through 180 degrees. You do realize that I have not indicated the direction for 180 degrees because either direction will just map the object to the given image. So this is for 180 degrees. If we do a 180 degrees rotation, A will be mapped to C and B will be mapped to D. So if we take a matrix of transformation which is A, B, C, D, we multiply by the object coordinates. The objects are A and B, so we have 0, 1 and 1, 0 should give us the image coordinates, and the image are C and D respectively. So we take 0, -1 and -1, 0. So let's multiply this. The first row multiplied by the first column will be 0 multiplied by A, which is 0, plus B multiplied by 1, which is B, is equals to the first x coordinate, which is 0. This means that B is equals to 0. The first row multiplied by the second column will give us the second x coordinate, which is -1. So A multiplied by 1 is A, plus B multiplied by 0 is 0, is equals to -1. This means that A is equal to -1. We take the second row multiplied by the first column, and we'll have C multiplied by 0, which is 0, plus D multiplied by 1, which is D, is equals to the first y coordinate, which is -1. So the value of D is equal to -1. And lastly, we have the second row multiplied by the second column. So C multiplied by 1 is C, plus D multiplied by 0 is 0, is equals to the last coordinate of y, which is 0. So this means that the value of C is 0. Therefore, the matrix of transformation is given as the value of A, which is -1, the value of B, which is 0, the value of C, which is 0, and the value of D, which is -1. So this is the matrix of transformation to represent a 180 degrees rotation. We can confirm from the table given, and true, that is the matrix which was given. Now we are going to use a trick that I'm going to give you for us to find the same matrices of transformation, and this is the trick. For the trick, we'll go in the anti-clockwise direction, leaving the first quadrant. This is the first quadrant, the second, the third, and the fourth. So we will exclude the first quadrant, and then we move in anti-clockwise direction. So this means that the first one will move from A to D, then we go from D to C, and lastly from C to B. The first quadrant is not included. So you should note that the second quadrant will represent our positive quarter turn. That is 90 degrees in anti-clockwise direction. And this is how we'll check. We'll take A going to D. The coordinates of A are 0, 1, and the coordinates of D are -1, 0. So this should be the matrix to represent a positive quarter turn. Let us confirm from the table, and that is true. Now we check the negative quarter turn. This is the positive quarter turn. It is confirmed. Now we check the negative quarter turn, and for our trick, the positive quarter turn will be directly opposite to the negative quarter turn. So this is the negative quarter turn, which is also called 90 degrees in clockwise direction. And this is how we get the matrix using the trick. We are moving from C to B, so the coordinates of C, then the coordinates of B should give us the matrix of that transformation. So C has the coordinates 0, -1, and B has the coordinates 1, 0. We can confirm this from the table, and the table gives us 0, 1, -1, 0. That is for the negative quarter turn, so that one is confirmed. And lastly, we look at the trick for 180, and the third quadrant is the one which represents the rotation through 180 degrees. So we are moving from D to C, D to C, and the coordinates for C and D should give us the matrix of transformation. So D is -1, 0, and C is 0, -1. We can confirm that one from the given information, and true to it. That is the matrix of transformation representing rotation through 180 degrees. That is the end of this lesson. Thank you for listening. I hope you understood.